From ContainerDays Hamburg, this video is proudly presented by Dux IT.
All right, so thank you folks for coming to my session. Appreciate that. My name is Federico. I'm a staff engineer for TransferWise. My background is consultancy. I worked in consultancy for financial services for many years, from Contino to Curve to other companies as well. Today, we're going to talk about multi-cloud and porting an application from AWS to GCP. I have too many slides for only 30 minutes, so we're going to skip through a few of them. I'm going to go really quick. Takeaway of the slides is that Kubernetes is old. Its technology is at least 10 years, if not more. Kelsey said today that it's 11 years old. The reality is that everybody adopts, or most people adopt Kubernetes because they say that with Kube, I can port my applications from one cloud provider to the other, right? So this is the big promise. Today, all together, like the group here, we're going to test whether that is true or not. We are a migration team together, which means that this is an interactive session. I have 4 or 5 slides with a quiz for you. So we're going to try to do it together and see how that goes. It's going to be really easy. It's super straightforward, but it's a good way, I think, to engage people. Also because it's getting late in the evening, so I want to keep the energy up. What are we doing together as a migration team? So in our company, we have been tasked to move this application running on Kubernetes on AWS, so on EKS, on GCP, on GKE. That is the story. What are the rules of our game together? The rules are that the landing zone on GCP has been built already. It's up and running. GKE is up and running. This is a migration where we can stop the world, okay? So I don't care about managing ingress management. I don't care about moving data across from our users. I can just stop AWS, move everything over, start GCP. We have a modern tech stack, which we'll see in a moment, with 3 GCP, this is 3, not 4, 3 GCP Golang microservices. So it's super modern, it's pretty easy. The important thing is we're doing together an easy technical migration. Nothing too complex, nothing too hard, really easy. But we do have lots of stakeholders. Our stakeholders are backend developers, front-end developers, the security team, our users that need to use the app, and the SRE or infra team that we have. How does the app look like? This is the easiest app we've ever seen. Our users use a mobile application, Android or iOS, doesn't matter. The mobile application talks to a microservice number 1, RESTful API on EKS, on AWS. We upload a photo, and from the RESTful API, microservice number 1, the photo goes on S3. From S3, it gets fetched by a microservice number 2 that does something with it, like adds a watermark, changes the colors, whatever you want, and then tells microservice number 3, hey, we change the photo uploaded by the user, send the user an email, a message. Just super straightforward. The user uploads an image, we change some color, we send the email to a user. In doing so, we use a few services. So we use a Postgres database running on RDS. We use SNS for messages for queuing on AWS. We use Prometheus and Grafana. And we use HashiCorp Vault on AWS. How does it look like? On GCP, we have defined the architecture already. It's the same thing, pretty straightforward. Users upload the image, goes to microservice, goes to cloud storage bucket, it's the same thing. Then we have Postgres running on Cloud SQL, managed on GCP, and we have PubSub that replaces SNS. That is pretty much a game. We're still using our third party to send emails out. Little icon on top right says GCP Secrets Manager replaces HashiCorp Vault. So very similar set of services. We have our journey. We're 6 minutes in. We're just going to go together. The big promise is, remember, the promise is Kubernetes. I want to be able to just take my YAML, change the destination and apply, kube control apply the YAML onto the GKE cluster. So how did the YAML look like? This is the YAML. The YAML that describes my deployment with my microservice number 1 or number 2, whatever you want. Can I run this? First question. Can I kube control apply this manifest, semi-manifest on GKE? Yes or no? No. Perfect. Why? The image, right? Somebody said the image. But can I not pull images from ECR from GKE? Of course I can. Yes, I can, but I need to give the GKE nodes some authentication. So I need to tell GKE, this is how you pull images from. This is a bit of a problem, once again, because if I do that, I lose the ability of using manage nodes on GKE. So I need to manage my own nodes. Bit of a trade-off in there, right? So what are the alternatives? And we're exploring this together. I have 3 options. Option 1, I can keep the container registry on ECR and pull from GKE, as we said. I can do it, but I lose the ability of using manage nodes. No bueno. I need to update my nodes if I do that over time, patch them, whatever. Option 2, I can use something like Harbor or Artifactory that I can import into the cluster, and then I just move them with me when I move to GKE. I can do that. So I import inside the cluster using CNCF projects or commercial ones to store my images, so I can import the images with me. Option 3, I just move to Google Container Registry. That, for all intents and purposes, is very similar to ECR on AWS. In our case, we're just moving because we're really easy. So the 2 services are very easy to move across. There is a bit of a trade-off in doing that, though. Moving that across. What is a trade-off? The trade-off is that there is a feature on GKE called binary authorization. Binary authorization says, as an organization, only images that are signed with our own keys can be deployed on our clusters. This feature doesn't exist on AWS EKS. And the CIS benchmark, the NIST benchmark, the best practices that we should follow when we use GKE now contain this best practice. This is a bit of a problem. Why? Because, as you know, if you work in a large enterprise, the way in which we adopt Kubernetes and those services, similar services, is based on best practices in the industry, right? So there's a best practice on GKE that doesn't exist on EKS. I need to change my controls. That is another thing that we're learning now. We're learning that because the services are not one-to-one mapping, the set of controls, best practices, company policies that I set up on one side don't work on the other side. Second change that I have to do when I adopt a different cloud provider. But in our case, our security team says, go with the flow. We're super easy. We're a chilled security team. So just go ahead. So we're continuing our journey. We're moving to ECR, kube control apply. Can I apply this into my new Kubernetes cluster on GCP? Yes or no? OK, who says yes? Raise their hands. I don't see anybody raising their hands. So who says no, then? OK, a few people. Any ideas why no? Why can't it work? Perfect, database. Can I connect from a RDS database from GCP? Of course I can. I can do that. I pay some latency cost. Latency is not that big. As I'm sure some of you have tried, latency between cloud providers is virtually indie latency, so under 10 milliseconds is really good. But still, we probably don't want to do it. So what do? We move from from RDS to Cloud SQL. The good news is that those 2 services are remarkably more similar in 2025 than they were a few years ago. Yes, networking model changes on GCP because of some way in which GCP does things, and authentication changes, but in 2025, they're the same service, so I can move it easily across. I still need to move inside the cluster. The other option, as we said before, would be to just import the Postgres database inside my cluster. If I import Postgres rather than depending on RDS, then I just move it with my app. as usual, if I do this, it's pretty straightforward. There are Postgres operators, there's a number of things, but I get portability and I increase my maintenance cost. If I import Postgres into the cluster, I have to pay for maintenance of Postgres. Pretty straightforward, no surprises here. This is the second takeaway of the session, right? The first takeaway was we have to change our controls, so this is a big process problem. The second takeaway, the more I make the application portable, because I stay within the Kubernetes ecosystem, the more I pay in long-term maintenance cost. It's a trade-off that I'm doing here. What is the likelihood of migration, the cost of migration, and the price I want to pay in terms of options now? So we have to think about the business case, and we can model it. Like, I think there's lots of financial modeling you can do in this case as well that I want to do maybe in a future talk. So, but either way, we're going with the flow. We're happy people. We change database engine. We are on Cloud SQL now. I go ahead and I deploy my microservices on GKE. Happy times, all the microservices up and running. My monitoring says everything looks good. So I go and tell my users, hey users, upload your photos, everything is fine. Users upload their photos and they get, whoops, 500. Why? Sorry, can you say that again? Yeah. So the API hasn't changed. We use the same thing. The failure is when the user uploads the photo, right? Any ideas? We said at the beginning, the architecture at the beginning. I'm sure that if I show you the architecture, it's super easy, but so this was the architecture at the beginning, I think. So a user uploads the photo and uploads the photo to S3 once again. So now the application is like, oops, where is S3? Who am I? Can I use S3 or not? So this is the thing. Okay, here. So can I use S3 from GCP? Yes, of course I can. Once again, I need to use my authentication and everything. There's more nuance around all of this, right? So swap one thing for the other. The storage buckets are very much similar logically and physically if you want as well. So what are the options? Once again, I can keep the object storage on S3, but comes at a cost and everything. Option 2, I can move things across. And the S3 is the de facto market standard, so the other cloud providers have an S3 compatible mode, which means that I can set my Google Cloud Storage buckets in S3 compatibility mode, and I can then use it with Boto, with the AWS SDK, right? So this is really powerful as well because I don't need to change the app. Or I do the usual thing. I import a service that looks like S3, like an object storage, within the cluster, but then I have to maintain it. A few options. Within the options, we also have the ability of using container storage interfaces. They have been talked about a lot. What I can do now is that I maybe don't need to explain this here, but what I can do now is I have persistent volume that can be backed by effectively an S3 bucket. So the application writes on the volume. The volume is S3 behind the scenes. If I change the container storage interface to the fuse mount, I can then swap it to cloud storage. So the application writes to a folder that is local to the host, but this folder is backed by a bucket that then changes behind the scenes. It's a way, once again, of achieving portability, trying to stay within Kubernetes. It's a cool feature, but there are trade-offs as well. It's a fuse mount, so it's not POSIX compliance. There are some limitations, a variety of things. It works. It's fairly stable. People are using it all the time, but it's just not perfect. And there's an interesting as well comparison. There are lots of options around this. In our case, we are happy people. We go ahead and we just move to the storage buckets. No problems for us. Changing the storage bucket, changing the storage technology though, is not a problem if you're moving one microservice. But what if your application is 1,000 microservices? What do you do then? Do I have to change the SDK? Do I have to change your library for 1,000 microservices? That could be a problem. None of this is new. The alternative we have within a Kubernetes cluster, there are lots of microservices deployed, would be to add a facade, an anti-corruption layer, effectively a service within the cluster, so another dedicated microservice that acts as an intermediary before reaching out to S3. This is great. It means that if I can change 1, 2, 3 microservices just by changing this anti-corruption layer and then talking to S3. Amazing. If I think about things beforehand, if I know that at some point I'm moving away from one cloud provider to the other, I can do it. I'm paying a trade-off here, once again, which is now I have something in the chain. So what if the anti-corruption layer fails? But it says yes to the application that made the call. I start losing consistency, right? Because I had a piece in the chain. It's an option. It's out there if you think about this. Continuing the journey, unafraid. So we change database. We change everything. The application is up and running. Everything is fine. Question, can I kube control apply my application here? We had this Q endpoint that says my Kube endpoint used to be sns.amazon AWS. I go to GCP and I'm swapping it with pub/sub. Can I do it? Can I just change the environment variables and saying, used to be SNS on the Q endpoint, can I go to pub/sub on GCP? Yes or no? People say no. Why? Totally. It's totally right. It's a different API. It's a different system. But why can I not do it? Because if you think about this, like what I need to do for my super simple use case is to send a message from one service to the other. It's a standard pattern that has been in the industry for 40 years. Okay? Nothing of this is new. Why can I not do it from a logical perspective? Yeah, the API is different. And I'm sure that pub/sub has features that are totally different from the features of SNS and very advanced. But our use case is a cursor use case where we just use a small thing. So let's think about that. Let's park that for a second. Why can I not do it? What are the options? As usual, I can, from GCP, connect to SNS, not a problem. I can swap it for pub/sub, but I need to change the library, or I can import an option within Kubernetes. As we said, though, I can change a library, but it's a very long thing to do, and I didn't want to do it. I make a super simple use of this service. Right? I don't need all the advanced features. I don't need the dead letter queues. I don't need timeouts. I don't need complex routing. I just want to send a message from one microservice to the other. So there are solutions to this. There is a CNCF open source project called Dapper. Who here has heard of Dapper? Few people, most people raise their hands. Okay, so what is Dapper? How does it work? It's a project that is backed by Microsoft that was released in 2019. This is the description of it, but it's a super simple thing. The idea is to use the sidecar container pattern and to say, okay, rather than reaching out to this external service directly, the application talks to the sidecar container that then talks to the third party outside. Okay? By talking to the sidecar container, then it becomes way easier. So I don't make a call to SNS or I don't make a call to pub/sub. I just talk to my sidecar container. And then the container within its configuration relays the message for me. Just to make it visual, microservice 1 used to go to SNS, then would go to microservice 2. Now, microservice 1 goes to Dapper that reads its own configuration and then goes to SNS. And then there's a Dapper on the other side that reads or gets a message from SNS, which means that I can swap SNS for pub/sub without having to do any application changes, which is really cool. So I can start doing what I was telling you before. I can start just changing the configuration of Dapper rather than changing the library of the application. Way more simple. And if you want, third takeaway at a high level of the talk, which is to increase portability. The trend to increase portability is to reflect the changes in the configuration, reflect the changes in the configuration in the open source ecosystem that supports this journey. So Dapper is super advanced, it's really cool, does like a million things, and doesn't only cover the pub/sub model, the Kube model. It does actor, state management, bindings, service discovery. It does lots of things, lots of things. It's not perfect. Why? Because if I use Dapper, well, I lose flexibility, right? I lose, for example, Advanced use cases, if Dapper manages which queue or topic I'm talking to, well, then I cannot change it in the application. I need to rely on Dapper. Maybe Dapper is less flexible than I am. If I want to subscribe to something and then subscribe to something else during the life cycle of the application, I cannot do it. But Dapper is really cool. The only logical problem with Dapper and the limitation with the open source tooling around this, similar to Dapper, is in something very specific. So, as we said, let's just look at secrets. Dapper supports secrets as well. Supports, as I said, a million things. Among the secrets that Dapper supports, you can see in the center, supports GCP Secrets Manager and supports HashiCorp Vault. We started from Vault that was running on AWS, and we move to Secrets Manager. We use the Dapper standard pattern, which is Dapper mediates a vault, swap for a secret manager. The application doesn't see any changes. They're happy. It takes them like, it's super easy, right? What is the problem? The problem is that if you look at our application source code, sample source code here, if you look down, there's a feature that this is a secret, the secret that was stored in our secrets manager store and secret store, and this secret has 2 keys and 2 values. Maybe not a surprise, maybe a standard thing, but this feature is a feature of HashiCorp Vault that doesn't exist on GCP Secrets Manager. This is a problem. This is the core problem with Dapper and all the services that try to build a abstraction layer on top of cloud providers. Which means Dapper, because it supports, as we saw a minute ago, like all of these different players for each feature, well, it cannot support all the features of all the players. It needs to rely on the minimum common denominator, the minimum set of features that everybody adopts. So this is what I lose by moving to this open source application. If I add an abstraction layer on top, I lose the advanced features, I lose flexibility, I lose the speed and the velocity that using that feature within HashiCorp Vault I would have gotten, right? So this is the problem with Dapper. And another, if you want, takeaway of the session, think about this. Takeaway of the session being open source, amazing. These tools do work. They really enable you to continue with the journey, but they also limit your flexibility, the minimum common denominator problem. Okay, continue with our journey. We have 5 more minutes before the end of the talk or so we have to be precise. We're deploying our application. Everything is up and running. All our systems are up. Our users upload their photos. They are super happy. Our InfoSec team is super happy. So, question. Why is our SRE team coming to us, screaming at us? Why are they screaming at us? What are these guys upset about? Somebody said no monitoring. It's a valid point. We'll talk about it a bit later. So I've done this talk at other conferences, so this is always, almost nobody gets this one. But I'll give you a hint. So what is the hint? The SRE team is screaming at us. This is the hint, because when we define the resources, we have Terraform on a trash can. So why are they upset with us? Somebody said state. So the reality is that when we moved from AWS to GCP, we had everything in Terraform code, right? But we are a migration team. We know nothing of Terraform code. We're Kubernetes people. What is this Terraform thing, right? So we just went ahead and created like all our resources, our RDS clusters, our PubSub on the console. Just went on the console and created that. The SRE team says, you guys, you don't know what you're doing. You just use infras code and everything. But we're like, if I define everything in Terraform and AWS and I go to GCP, I have to rewrite everything. There's no magic there, right? I rewrite everything. So is there not a better way? Open source comes to our help. Crossplane. Most of you must have heard of Crossplane, I suspect. Raise your hands if you have. So I can, yeah, exactly, I suspect. Most people have heard of it. Crossplane allows you to deploy resources that are external to the cluster, infra resources of a cloud provider. Those infra resources can be described as YAML. Very complex way of saying something really simple, which is I need an S3 bucket. I describe the S3 bucket as a YAML, kube control apply, and then Crossplane operator says, oh, I have this new resource here. I'm just going to create a bucket for you and give you the bucket. This is cool, but there's more to that, right? So what I can start doing, I start creating composite resources. So I can start saying, I not only need a RDS database, sorry, Cloud SQL database with a whole bunch of firewalls and authentication. I need a composite resource that I call Postgres instance that contains all of this. This composite resource can be cloud provider independent. So I can define it in a way that I just say, give me a Postgres database. Then I configure Crossplane behind the scenes to provision this database for me outside, right? So by doing this, I can effectively become independent of the cloud provider I'm using because the swap happens behind the scenes and is, once again, managing configuration by the infra team. Crossplane enables us not having to rewrite all our infra code. So we're on our journey. We're continuing our journey. We're there. We've done secrets management. We've done our infra deployment with Crossplane, so things are way easier to move around. Will it work now? Of course it works. Everything is up and running. Our users can upload things, and the monitoring concern that was raised a minute ago has been addressed. Why? Because when we were on AWS, we had several options to do monitoring on AWS. We could have used something like CloudWatch, super powerful, or use something like Manage Prometheus and Grafana. By using open source tooling, Manage Prometheus and Grafana, we can go to GCP and take our dashboards, our alerting with us, because it's a standard set of APIs. So we use open source to simplify things, as we did throughout. Clearly, if you define your dashboards with CloudWatch and then you go to GCP, that becomes way harder to move them across. There's no tooling that lets you do that, right? So once again, open source comes to our help. Okay, so what are the takeaways of this short session? So at a high level, Kubernetes is the reason why cloud portability is so hard is that Kubernetes is not feature complete. So I can put everything into Kube. I can put one container, and I can easily move that container across. But I can't put an entire application, because the application has dependencies on a set of other cloud provider services, which means that cloud portability is really hard work. Moving things across is not as simple as it sounds, even if you're using Kubernetes, even if you're using all the advanced features that open source has. And there's a clear economic, concrete cost attached to it that needs to be modeled. If you think about moving stuff across, you have to think at how much I'm spending now to making my service portable, how much am I going to spend in the future when it will come down to porting the service to actually do the final changes. Few takeaways for us today. First takeaway, clearly the ecosystem plays a big role in this. Open source simplifies portability. Portability goes against maintenance cost. The more I'm portable, the more I pay in maintenance, the more I pay in velocity. I'm slower if I'm more portable. But it's a trade-off that I can make. Other takeaway, portability has a clear monetary cost attached to it. Some of our open source tooling can help us moving across and being faster at doing things, but we have to think about this. Okay, hope this was interesting for you. Thank you for coming, folks.
How can cross-cloud data migration be done with Crossplane?
Okay, so that's a good question as well. So data gravity, I ignore the problem throughout the talk, right? So I ignore the fact that we have data in a database and we have to move that across. Crossplane doesn't worry about that. Crossplane doesn't let you move a data set either in a bucket or on a database or anywhere across. So you have that. Crossplane doesn't help you. You need to do a migration and think about the data migration. There is like a million different ways to perform data migration, and they're very much technology dependent. So Crossplane won't help you with that.
Okay. Any question in the audience, perhaps? Okay, I have one, if I'm allowed to. Yes, I can. Okay. Even if you're moving your pods from AKS to GKE, each cluster has its very specific implementation, meaning even though you can move your pods, there might be some, for example, the IAM that exists on AWS doesn't exist in the same way in Google. So there's also other concerns than simple secrets and stuff. How do you manage that? Like, you have the full IAM implementation in AWS, and how do you make sure that when you move your workload into GKE, you're not losing everything or breaking everything regarding to this?
Yeah, it's a fair point. So there are two layers to that question. Like one layer, which is the way in which GCP and AWS they do IAM is different. AWS is everything is on an account. GCP is way more on projects, folders, and the hierarchical nature of that. That is one problem, which in itself means that the way in which you're modeling things is different. The second part of the question is, what about Kubernetes and the workloads? So in my view, in reality, the way in which you're telling a workload that here is how you're supposed to authenticate to the cloud providers is very much standard. So you're tagging the service account, right? So the workload sort of like doesn't see that in itself. You have to change how the workloads, though, is consuming this information. So I know that this is my service account, but if I'm using the Google Cloud SDK and I'm reading some AWS credentials with it, not going to do anything with it. You have to port across. I don't talk about it because the Kubernetes layer is the same, but the implementation changes behind the scenes.
So what would be then your best advice to do that?
You have to change it. Like you have to think about how you're going to change it over time. There is no magic there. I think that I don't know of any ways right now in configuration for which you can just swap it without changing the app. You have to change the app. You have to change the SDK of the app.
Okay. Well, thank you for answering my question.
Perfect.
Any one last question in the audience before the after party? I'm not rushing you to go to the after party. If you have questions, we have time. So just raise your hands. We have Mike.
Well, if there...
Ah, there we are.
In your talk, you basically ditched the option of insourcing certain databases, for example, or other APIs. You said this is expensive. But I have to say, don't you realize that with the way you've done this, you just did a big refactoring of your application and probably changed it all across just to land up in a different cloud, and now you're stuck with GCP instead of AWS or whatever the change was?
Yeah.
Isn't that a problem?
Like, that's a very good question. The question is
you don't really have relocatability, right? You can't just easily change to another, let's say, Oracle Cloud or Hetzner Cloud or whatever, because that would end up in another big refactoring.
Yeah, so that's a good question. So, as we said, the talk says that you can use some open source tooling to simplify porting things across cloud providers, right? Pretty much. And you can use some of these best practices to simplify things. You can, as we saw, we could use this facade, this microservice within the cluster that allows us to change things behind the scenes. But the actual answer to your question, I think, is that you need to make a trade-off, right? So when you're defining an application, you're effectively defining an option. You're defining an option. What is the likelihood that I'm changing the application, that I'm moving to a different cloud provider? How much am I willing to pay? I don't think that you should, at day zero, when you're building the app, you should think about, oh, I'm going to make everything super portable because there's a 5% chance that in 5 years from now, I'm going to go to GCP, and then a 0.5% chance that I'm going to do GCP and Oracle. I think that you should make a conscious choice where you say, this is how much I'm going to spend now, today, in today's money, into defining using these portability features, and how much I want to spend in the future to then optimizing. The game there is to say, I think, optimizing the present and giving yourself some time for the future to change it. You shouldn't go to zero today because it's too expensive and you're paying too much for something that may never materialize. You should try to strike that balance between how much I'm spending today and how much I'm spending in the future to then change the application again, because it's very unlikely for me to change 2 cloud providers in a short period of time. So there's no answer on that, I think. But it's a very good question, so thank you.
One last. 3, 2, 1. Okay, let's close for today. Thanks a lot for your talk. I will then engage you to enjoy the after party and have some fun all together.
Thanks, folks.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.